Hi, and welcome to our third lesson of Unit 9. Today we are going to be sticking with volume, but today we are going to be talking about finding the volume of prisms using a formula. A lot of our work today should look very similar to the work that you've done in 5th grade, and we're going to start by doing a quick refresher about how we found the volume of prisms by packing them in our last lesson. This should look familiar. In our last lesson, we found the volume of this figure by packing it with 1/2 by 1/2 by 1/2 inch cubes. What we first did was figure out how many 1/2 inch cubes fit along the length of our prism. Then we figured out how many fit across the width and across the height. Then we found the total number of 1/2 inch cubes that fit in this prism was 192. Then we found the volume of each of our smaller 1/2 inch cubes was 1/8 cubic inches. Then in our last step, we multiplied the number of 1/2 inch cubes by the volume of each 1/2 inch cube to find the total volume of this figure, which was 24 cubic inches. That was a long process, and we're going to need to remember that through the rest of this unit. What we're going to be doing today is sticking with volume, but we are going to see if our volume formula still works even when we're working with fractional side lengths. So the first problem that we are going to look at today is this one right here. It says find the volume of the figure below. And you can see we're given a length of 1.5 inches, a width of 1 inch, and a height of 2 inches. We could use the method that we just went over of packing this prism. But we also know that we have a volume formula, which you see on the screen. Volume equals length times width times height. Now, what makes this problem different than most of the volume problems we've solved in 5th grade is that, as you can see here, we have fractions in our side lengths. In this case, it's only in our length, but we'll be solving problems today where our dimensions often include a fraction or a mixed number. So we know from 5th grade that we can substitute our length, our width, and our height into this volume formula. Volume equals 1 1/2 times 1 times 2. When I say go, pause the video and simplify this expression on your own. Your teacher is going to cold call somebody in 30 seconds to share out their answer before we come back together and you can check your answer with mine. Ready? Go. Take a look at my answer. I wrote volume equals 3. Do you agree or disagree with my answer? When I say go, you'll pause the video and vote in Zoom, yes, I agree the answer is 3, or no, I disagree. Ready? Go. If you voted yes, you were on the right track. When you multiply 1.5 times 1 times 2, you do get 3. But we know anytime we are finding the volume, we must have our units. So when I see volume equals 3, I could say 3 cats, or 3 dogs, or 3 ice cream cones. But we know in this case, our volume is referring to 3 cubic inches. Anytime you are solving volume, remember to include your units. Volume equals 3 cubic inches. Now, we could check our work here by packing this prism with smaller cubes. Since we refreshed at the beginning, and you guys are experts on that from yesterday, I'm going to move us straight to stamping our key point. Our key point for today is the volume formulas can be applied to rectangular prisms with fractional side lengths. Now let's solve one more problem together. The problem says, what is the volume of the rectangular prism? As you'll notice, we have dimensions that have fractional side lengths. We know we can substitute our dimensions into our volume formula. Volume equals length times width times height. When I say go, pause the video and solve for the volume of this figure by substituting into our volume formula. Be ready to check your answer with mine in 60 seconds. Ready? Go. Check your work with mine. You'll notice that I got my final answer as volume equals 7 1/2 cubic inches. If you also got that, go ahead back into Zoom and give yourself a virtual clapping of your hands so that your teacher can know that you solved this problem correctly. Go ahead and do that now. We're going to take a look at one more problem together. It says, what is the volume of the rectangular prism below? Now, my question for you is, we have 2 volume formulas from 5th grade. Volume equals length times width times height, and volume equals base times height. Which of these two volume formulas should we use for this problem, and why? In a second, we're going to vote, and then your teacher is going to call on one scholar to explain their thinking before we come back together. When I say vote, hold up a 1 if you think Formula 1, or a 2 if you think Formula 2. Be ready for a cold call. Ready? Vote. If you voted for Formula 2, you were exactly right. In this case, we are given the base area, which is 1/4 meters squared, and we are given the height, which is 1.5 meters. Therefore, we need to use our second volume formula. Now that we know which formula we are using, when I say go, pause the video, take 30 seconds to substitute and find your final volume. Ready? Go. Check your work with mine. One thing to point out here is notice that in our first step, we had to convert our mixed number of 1.5 into a fraction greater than 1, which was 3/2, so that we could multiply. We therefore got a final answer of 3/8 cubic meters. If you got this correct, go ahead back into Zoom and give yourself a virtual clapping hand so your teachers and your classmates can see that you got this correct with all your hard work. In all of the problems we solved today, we used our key point, which was that we could use our volume formulas to find the volume of a rectangular prism even when there are fractional side lengths. Before we begin our work, take 30 seconds to read over our CFS for top quality work. This should look very familiar because they're often very similar when we are working with volume. The one I want to draw your attention to is the third one that says formula is written based on the information provided. Just as we saw in our last example, sometimes we'll be given information such as length, width, and height, and we'll use our volume equals length times width times height formula. Other times we may be given a base area and a height, in which case we should use volume equals base area times height as our formula. And don't forget your units in all of your work today. That is it for our video today. I'm excited to dive into the second half of Unit 9 with you all the next time we see each other. Have a great rest of your day.